Hello guys. Today's question is about number of people aware of a secret. So they will give three integers: n, delay, forget. So n is about the number of days, and delay is if a person knows the secret, they can share that secret to other person after a delay days. And forget, after knowing a secret, they will forget after forget days. So we have to return the number of people knows the secret at the end of the day. Yeah. So as you can see here, n equal to 6, delay equal to 2, forget equal to 4. So for the first day, first person will know, which is named as A, will know about that secret. And A is the only person who knows the secret on the second day. He can't share that secret to others because delay is 2. On day 3, A can share the secret because he after delay days, he can share. So that A shares the secret to a person B, which is now two people. So on day 4, now A shares this secret with a new person C. So now we have three people A, B, C. And at day 5, we know that after forget days, I mean 4 days, A will forget the secret. Now B, which completed 2 days, means delay days. So now he can share a secret with new persons. So now B shares secret with a new person D. Now also we have three peoples B, C, and D. On day 6, B shares a secret with E, and she shares because C lends the secret at day 4. Now he reached after delayed days. I mean after 2 days. Now he can share that secret. So he shared with another person. So at last, five people knows the secret. So the answer may be lost. So we have to return in a modulo 10 power 9 plus 7. So now what we will do is we use DQ to manage people dynamically. Why DQ? DQ is efficient to pop from front or from back, or push from back or push from front. So we use DQ here. So we use two DQs, no and share. No will people who knows the secret but aren't allowed to share. I means there is a waiting period. He they didn't reach the delay period time, so they just know the secret. They are not allowed to share. And for the share, people who can share but haven't forgotten yet. So share contains the people who can share but they have not forgotten about the secret. So each element for in DQ we use pair of int. So that means two integers. One is day and two is count. For day, the day is the group of people learn the secret, and the second one is count. So how many people learned that secret on that day? By using these, we can calculate how many of the people knows the secret at the end of the day. So let's first declare the mod. I'll write like this so that I can know that the correct number of zeros. Okay. Now dq of pair of int and int, and we know that two are no and share. And we have two counters. One is share count, and another is non count. Here both share count and non count is nothing but share count is 0 because on the first day there are no persons which we can share the secret to another, and at non count which is 1 because one person already know about the secret. And for also in DQ we will emplace back the first person. This is the day. On first day, number of persons known on the first day is 1. That's it. And we will try to loop from I equal to 2 to I less than or equal to n. and I plus plus. So there are three cases. There are three cases. First case is, so the first case is all about the person who completed the delayed X. So the person who are eligible to share the secret. So to check that, if not of no dot empty and then no of zero dot first is equal to I minus delay. Why I minus delay? On the day minus the delay, I mean, check here on day 3, 3 minus 2, which is 1. On first day, A knows the secret. So now, after completing the delay days, he can share now. So that's why we use I minus delay. And now, so that he can share now. So we will remove that person in noun counter minus no of 0 dot second. Why second? Because it contains the number of persons who know the secret. And we will add more in case if there is any overflow. And person more. Now they can share so that we will increment share count. Share count plus no of 0 dot second. And we will do percentile module. Now we can emplace back in share DQ as no of 0. Now after removing from no count and share and adding it into share count, so that we have to pop it. So dot pop front of, that's it. That's it. And the second scenario is, now the person will forget the secret. Now we have to check if that person forgets that secret, then we have to remove from the share count and the share dict. So not of share dot empty and then share of 0 dot first equal to I minus forget. Same as it is in I minus delay, same as I minus forget. Now share count equal to brackets share count minus share of 0 dot second plus plus mod to avoid overflow and person module. And after that, we will remove from share dot pop front. Okay. After this, now, and the third step is, we know when they will eligible to share the secret and when they will eligible to forget the secret. I mean, forget the secret. So now, what about the sharing? For the third case, the people who are eligible for sharing the secret will tell tell to new person about the secret. So for that, we know that someone is there to share the secret. So we will check that if the share disk is not empty, then the person who know the secret will be increase share known count plus share count. Why known plus share count? One person at most can deliver that secret to another one person only. So that if there are two persons who can share, they will tell to another two. If there are four, they will tell to another four, like that. and person more. After this, we have to push in. After that, we will emplace it back, uh, like I comma, no count. After this happen, we'll simply return no count plus air count person more. That's it. Mm, wait, I think I made a mistake somewhere. Yeah, here. We don't have to push only share count because two persons will share at most two persons. So that we have to push only share count. Yes. Okay. That's it. It's 0ms and you know the link will be in the comments so that you can view the code. Thank you.